So guys, welcome back. So we continue with section 4.2, and we talk here about shift matrices and circulant matrices. It's pretty easy stuff, okay? So first of all, my target today is very modest. I'd like to talk about shift matrices, circulant matrices, and convolution. Okay, first of all, what is an upward shift? So in fact, you see when this matrix P multiplies a vector X, the components of X are shifting upwards. So if you consider that this is P, and you do the simple matrix multiplication, and here you get X2 moves up, X3 moves up, X4 moves up. In fact, an X1 is like moving up, so it gets its turn to be on the last position. Okay? So in fact, the word cyclic and circular apply to P because the first component X1 moves to the end. So if we think of the numbers X1 and X2, X3 and X4 around the circle, P moves all of them one by one position. P squared, in fact, turns the circle by two positions. So this is in fact P squared, guys. Huh? In fact, if you can try to compute it, this is P squared. So it's exactly the same P you got here and multiplied by P again. So this is P times Px. This should give you P squared. And you see here they moved by two positions upwards. Okay, so every new factor of P, in fact, gives a new one additional shift. And if you consider that P is raised to the power 4, what you're going to have, in fact, you get a complete 360-degree turn. So in fact, P to the power 4 times X is just X. And in fact, P to the power 4 acts like the identity matrix of size 4. And of course, the next powers, P5, P6, P7, and P8 would repeat the pattern and cycle around again. Now, the next matrix is called circulant. It is simply a combination of these P's. And the last one, which is P to the power 4, which gives R. So in fact, it has constant diagonals. So if you consider that C, this is capital C for circulant, it is C0I, because you see that the C0 happens to be on the main diagonal here, plus C1P. You see that the C1 is spreading on the first upper diagonal. C2P squared, and C3. Okay? C3 is spread on the first lower diagonal. Okay? So now you can see that this circulant, this is called the circulant matrix. And C0I plus C1P plus C2P squared plus C3P3 is called the circulant matrix. So each diagonal in that matrix cycles around exactly like the ones in P, the ones in P. And the diagonal with C1, 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 C1 is completed by the fourth C1. The diagonal, I mean, talking about this upper diagonal, C1, C1, C1 is completed by the last item you see in the bottom, the last row. Okay? So, in fact, if you multiply two circulant matrices, like the one just defined in the previous slide, C and D, their product, CD equals DC, is again also a circulant matrix. So when you multiply CD, in fact, you are multiplying powers of P to get more powers of P. And DC is doing exactly the same. So let's take this example. So in this example, we have n equals 3. And P to the power 3 equals R. So let's first have a closer look at it. So these are the ones on the diagram, okay? and these are the 2's in the upper diagonal, and the 1 in the bottom, and these are difference. Okay. So these are in fact, two circulant matrices, C and D. This is a C, and this is D. If you do the matrix multiplication, you get another circulant matrix, which is 13, 22, 19, 19, 13, 22, and 22, 19, 13. Okay? In fact, this could have easily also been retrieved if you consider that this C is in fact, now this is C, it is in fact I plus 2p of size 3 plus 3p squared multiplied by 5i, you see 5 is on the diagonal here, plus just 4p squared. So if you do the simple expansion here, and expand, you get 5i plus 10p, plus for the p squared, you get 15. First of all, 3 times 5 from here. So you get 15, plus the other one when I hits the 4p squared. So you get 15 plus 4p squared. And you got 8p cubes plus 2p to the power 4. In fact, the p to the power 4, as you know, is I. Okay? So what you're going to get is how many i's? How many i's, first of all? You're going to get 13i, 22p, and 19p squared. Okay? So you see that these 13 and 22 and 19 are exactly the numbers which are shifting around in the circulant matrix. Okay? Which is interesting because, in fact, in this compact formulation, just using the shift matrices, you were able to get the circulant matrix. So at the last step, in fact, we needed and used the circular facts that p cube is r, because here, sorry, yeah, because we are in size 3. And p4, it gives you back p. So the vectors 1, 2, 3 for C and 5, 0, 4 for D produce the vector 13, 22, 19 for CD and DC. And this operation is quite important. It's called cyclic convolution. Cyclic convolution. Okay? So, but in fact, you knew convolution way before. In fact, you were very young when you studied convolution. It was in second grade, primary school. So, what is convolution? When we multiply, in fact, n by n circulant matrices, C and D, we take the cyclic convolution of the vectors C0, C1, C and xn minus 1, and D0, D1, D and xn minus 1. So this is for cyclic convolution. Now, ordinary convolution finds the coefficients when we multiply C0i plus C1p plus Cn minus 1p to the power n minus 1 times D0i, D1p till Dn minus 1p to the power n minus 1. So this is ordinary convolution, which finds the coefficients when we multiply C0i plus C1p plus Cn minus 1p to the power n minus 1 times D0i plus D1p plus d to the power n minus 1p to the power n minus 1. Then cyclic convolution, in fact, it uses the crucial fact that p to the power n will always give you r. So this is for the convolution, ordinary convolution. I'll explain here what it means, okay? And this is for the cyclic convolution. This is a mistake from my part. Here we should have gotten the 13, 22, 19. Yeah, 13, 22, 19. Okay, I think it was like this. And 13, 22, 19. Yes, exactly. 13, 22, 19. Okay, so in fact, ordinary convolution is the multiplication you learned a long time ago. Let's see what it means. in the second grade, when in fact it was made easier because there were no carrying to the next term. So if you multiply 1 to 3 by 504, here I'm distributing the 4, I'm multiplying, I get 12, 8, 4. On the next row, I get 0 by 3, 0 multiplied by 2, 0 multiplied by 1. And on the last, I get 5 by 3, 15, 5 by 2, 10, and 5 by 1. So if I sum them all now, I'm going to get 12, 8, 4 plus 15, 10, and 5. So this is in fact C multiplied by D by cyclic convolution, by ordinary convolution. Okay? So this is all what I have for you today, guys. So do you have any question on what we've